Share the screen. Maximize. All right. So today we're going to talk about factoring. All right. Factoring is not difficult if you understand what you're actually doing. Okay. I know, easier said than done there. Okay. So here's what we're looking at. When we multiply numbers, like 2 and 3, we know 2 times 3 equals 6. Okay. All these numbers actually have names. The 2 and the 3, they're called factors. So if you think about this, factors are just numbers. And I'm going to get a little bit more general here. We'll just say things. Number or things that are being multiplied. Okay? They're just number of things being multiplied. Any questions so far with that? All right. Now, the result is called the product. Now, I have 3 examples here. We'll start in the first blue one. 2 times 3 equals 6. We know 2 and a 3 are called factors. The result is the product. You can also have a factored form, which is using variables. We know when the bases are the same and you're multiplying, you add the exponents, right? That's chapter 12 material. But more importantly, things that are being multiplied are called factors. The result is called the product. In chapter 12, I gave you 2 binomials and I said, go ahead and multiply them. Tell me what it equals. Well, those 2 binomials were called factors. Okay? So those 2 binomials are called factors, and the result is your product. In chapter 13, what we're going to be doing is this. I am going to give you the product. I'm going to give you the answer. What I want you to tell me is, what were the things that you had to multiply to get the answer? Does that make sense? So we're going backwards. That's all we're doing. Okay? So the key concept here is factoring is the reverse process of multiplying. Like I said, I'm going to give you the answer. You got to tell me, oh, here are the things that we multiply to get that answer. Now, luckily for us, there are techniques that we're going to learn. There are techniques that we're going to use to help us with this. And the first technique is called the greatest common factor. Okay? So that's what this is in black right here. That's what we're going to be asking ourselves. That's the first thing we're going to ask ourselves. If I have an answer, is there a greatest common factor? Now, let me show you what that means, okay? If I ask you, find the GCF for 28 and 40, here's what I'm really asking you to do. Notice I wrote out, does anybody remember what those are called? What I wrote out right here? 28 equals 2 times 2 times 7. 40 equals 2 times 2 times 2 times 5. And it's exactly what it is. Okay? So if I wanted you to find the GCF for 2 numbers, 28 and 40, first thing you're going to want to do is you're going to think about, okay, what's the prime factorization? All right? Now, I did something special here. I highlighted 2 of the 2's in red and 2 of the 2's in blue. And the reason why I did that is because notice that in both these prime factorizations, they have at least 2 2's. They share 20. Oh, hold on a second. This marker's so thick. So 28 and 40 share, I don't want to say at least, we'll say at most 2 times 2, which equals 4. Or 2 2's. Does that make sense, everyone, so far? That's the GCF. So the GCF would be a number that both, let me say it like this. A GCF Sorry, I have to write it first so that I know how to say it. That's what I wanted to say right there. A GCF is a number that divides both factors evenly. In other words, 28 divided by 4 is 7. No remainder. That's what we mean by evenly. There's no remainder. So 28 divided by 4 is 7. 40 divided by 4 is 10. There's no remainder. That is the largest number that I can do that I can divide into both of those numbers. So if I'm asking you to find a GCF, what I'm really asking you, find that common number that divides evenly into both factors. Are there any questions so far? All right. Now, you can also do this with a list of terms. Personally, I think Objective 2, much easier than Objective 1. Objective 1 is understanding what a GCF is and how does that work with numbers. Objective 2 is finding this GCF for a list of terms. So when we're looking at the GCF of a list of terms, what I have here, hold on a second. Don't bite this. No biting. Come on. Go that way. There you go. When we're looking at a list of terms, I wrote, let's find a GCF for x to the third, x to the fifth, x to the seventh. I also wrote out their prime factorizations. X to the third is x times x times x. X to the fifth is x times x times x times x. I don't know if I said it. I don't know if I said 5 x's. Can't remember. And then x to the seventh is just x multiplied by itself 7 times. All right. Most importantly, here's what you're looking at. They all have at most 3 x's. So my GCF is going to be x to the third. Now, there is a little rule, and that's what's bolded in this nice box for us. From this example, we can see that the GCF of a list of common term or common variables raised to powers is nothing more than the smallest exponent. That's it. So when I look at x to the third, x to the fifth, x to the seventh, I just look for the smallest exponent, and that's going to be the GCF. Okay? Are there any questions there? Am I moving too fast? Are we okay? All right. Because I'm gonna scroll up. Going once. Going twice. All right, I'm scrolling all the way up. So here we go. In general, the greatest common factor of a list of terms is the product. Now, we know product means multiply. So it's the product of the GCF of the numerical coefficients and the GCF of the variable terms. Let me show you what I mean. I don't want anybody to write this down yet. I just want you to watch. Okay? My first example. Find the GCF for the following. 2 terms. 20x squared y squared and 6xy to the third. Now, the greatest common factor is going to be the product of... It's going to be the product of the numerical coefficients and the variable terms. So, here's what I do first. I'm going to find a GCF for the coefficients. And I'm going to really write this one out. But once we get going a little bit, I'm not going to do this as much. So 20. It's 2 times 2 times 5. 6 is 2 times 3. I'm looking for prime numbers that are shared. And that only occurs right there. They both have at least, or they both have at most 1, 2. Does that make sense? Yes or no? Okay. So my GCF for the coefficients equals 2. Now the GCF for my variables? Well, I have in the first term x squared y squared, and the second term x y to the third. They both share an x. The question becomes, what's the smallest exponent between those two terms? That's a 2, and that's a 1. So what's smaller, 1 or 2? What's smaller, 1 or 2?
1.
Perfect. So my GCF for the variables will be x to the first. Now let's look at the letter y. This is y to the second and y to the third. So it's going to be y to the second. So what I did is I found the GCF for the coefficients. I found the GCF for the variables. The GCF for the entire problem is the product of those two things. 2xy squared. Notice I just write everything as a multiplication. Does that make sense, everyone? All right, so go ahead and write this down. All right, so for the next one, and I'm color coding it now, so if you go back and you look at the definition, in green is a GCF for the numerical coefficients, and blue is that for the variables, and then the greatest common factor of a list of terms will be in red. Okay? So, for number 2, GCF for the coefficients. You have a 5, 15, and a 20. Don't worry about the negative. So 5, we know equals 5. 15 equals 3 times 5. And 20 equals 2 times 2 times 5. So what is the only number that all three of these numbers share?
5.
Perfect. So the GCF for the coefficients is 5. Now let's do the variables. So the variables, I have y to the fourth, y to the second, y to the third. What's the smallest exponent on the y's?
Y to the second.
Perfect. Therefore, the GCF for the terms 5y to the fourth, 15y to the second, and negative 20y to the third will be the product of these two. 5y to the second. Does that make sense, everyone? Okay? You'll see why we need to find this in the next objective. What I'd like you to do for me is go ahead and do number 3. Okay, we ready? Who got a GCF for that? Anybody can share. Remember, we're learning how to do this, so I'm not expecting right answers. What was your GCF for 4x squared, x cubed, and 3x to the 8th power?
Is it x to the second?
It's exactly what it is. Very good. You were a little apprehensive there, weren't you, Jada? A little nervous. Don't be nervous. Remember, we're learning this. If this was a job interview and your job was to teach math, then be nervous. You're learning this. So, GCF for the coefficients. Let's look at them. You got a 4, you got a 1, and you got a 3. Remember, that's a 1 right there. Is there anything in common? It's a yes or a no question. I agree with Amanda. GCF for the coefficients. None. Let me write that better. There isn't one. GCF for the variables. Well, let's look at the variables. You got x to the what? X to the second, x to the third, and x to the 8th. Smallest exponent. So it's going to equal x to the second. Therefore, your GCF for the entire problem is just x to the second, because you didn't have one for the numbers. That's okay. You're not always going to have, hey, here, newsflash. You might not even have a GCF. One might not exist. Then you just say, one doesn't exist. That's it. Are there any questions? All right, let's do the last one. Notice here, there are no coefficients. Well, there is a coefficient, but it's all the same number. It's a number 1. So, numerical coefficient GCF, there isn't one. So now I'm just going to focus on the variables. Remember, you are looking for the smallest exponent. For the letter A, it's a to the second. And for the letter B, it's b to the second. So your GCF is just a to the second, b to the second, okay? Are there any questions? All right, now, you might be asking yourself, okay, well, why are we finding this? Like, why are we finding a GCF? Remember, at the very start of class, factoring is the reverse of multiplication. At the start of this lecture, I said, I'm going to be giving you the answer. What I want you to tell me are what are the things that we multiplied to get that answer. And that's where we start actually using this GCF thing to our advantage. So objective 3 is finding out the greatest common factor for polynomials. So in general, the best way to find a GCF is exactly what we've been doing. You're going to be looking at the terms inside the polynomial. You're going to find a GCF for the numerical coefficients, and then you're going to find a GCF for the variables, and you're going to factor it out. So a simple example of what I'm talking about is something that we've all seen before, the distributive property. So if I start on the left, all right, now I'm going to zoom in here. If I start on the left over here, where I just put this star, and I said go ahead and multiply, then what you would do is you would distribute the A, and you would say, well, A times B plus A times C. Am I right? How many of us are familiar with that? Now, remember, left to right, you multiply. What I'm asking you to do is this. I want you to go from right to left. Notice I gave you the result. I gave you the answer. I want to know what are the things that you multiplied to get that. So if you look at this, we have two terms. We have the first term, which is AB, and we have the second term, which is AC. Notice in both terms, they have that letter A in common. So my GCF will equal A. Now that's what we just did in the previous examples. What I want you to do now is actually write it out. So to write this out, what we would do is once we decided what our GCF is, we would write it out front and put parentheses on the inside. Okay? We need to write something on the inside here. And here's how we get this. Give me 1 second here. I'm just going to rewrite something. All right. In this example, we are moving from right to left. What's the opposite of multiply? Because remember, if you go left to right, you're multiplying. So if you go from right to left, that's the opposite direction. What's the opposite operation of multiplying?
Dividing.
And watch what happens when I divide this, Jada. I'm going to divide each of my terms in the polynomial by the letter A. We know A over A reduces. And look what's left over. B plus C. And that's what goes inside the parentheses. In other words, once you find your GCF, put it out front, write parentheses, and I want you to divide every single term inside the polynomial by your GCF. And then you found the things that are being multiplied that give me the answer. Let me show you an example here. In example 5, we have 4t plus 12. My GCF here is going to be 4. That's it. Now, I did that really quick, but if you think about it, I looked at what's the GCF for the numerical coefficients. That's going to be a 4 because 4 divides into 4 and it divides into 12 without a remainder. So my GCF is 4. For the variables, there isn't one. The first term has a t, but that second term, the number 12, does not have a t. So I cannot factor out a t. Has to be common for every single term. So now that I've established, excuse me, that my GCF is 4, I'm going to write a 4 in parentheses. I should have gave myself a little bit of space here. Now that I know the GCF is 4, watch how I do this. Everybody, you got to watch the screen because you'll miss it. I'm going to divide all these terms by 4. I know 4 over 4 reduces, so I'm left over with a t. And 12 divided by 4 is 3. Now I'm going to erase that. Does that make sense, everyone? In other words, the answer is 4t plus 12. What did you multiply to get 4t plus 12? You've multiplied 4 times t plus 3. And here's the beautiful part. To check yourself, distribute. To check yourself, just distribute. If you get exactly what you should, which is at the beginning of the problem, you know you did it. You've done this correctly. Does that make sense, everyone? Are there any questions before we move on to the next example? All right, am I moving too fast? Are we okay? All right, I'm going to shut up and do the next example since no one's saying anything, okay? So for the next problem, y to the 8th plus y to the 4th. Let's factor it, okay? First thing we look for is a GCF. So I'm going to write it down here. There are the coefficients, they're both 1, so I don't have to worry about the coefficients, but I do have to worry about the variables. Y to the 8th versus y to the 4th. My GCF, hopefully, everyone knows is y to the fourth because it's a smaller exponent. Now that I know what my GCF is, I'm going to write it out front with parentheses. I'm going to divide all my terms by y to the fourth. This is why we need chapter 12, because you got to know how to divide this. Y to the eighth divided by y to the fourth. What is that? What is y to the eighth divided by y to the fourth?
8 minus 4.
Perfect. When the bases are the same, you subtract the exponents. 8 minus 4 is 4. Put a plus sign. For the second term, y to the fourth divided by y to the fourth is y to the 0 power. But what is y to the 0?
1.
Very good. There's your factored form. In other words, the answer is y to the eighth plus y to the fourth. What did you multiply to get that? Y to the fourth times the quantity y to the fourth plus 1. Is this making sense? Okay. Next one. Negative 8b to the sixth plus 16b to the fourth minus 8b to the second. All right. So let's find our GCF first. Now, I see these numbers, negative 8, 16, negative 8. What is the numerical coefficient GCF? In other words, when I'm looking at just the numbers, what's in common? Who said that?
Jaden.
Very good. It's an 8, okay? Now, I will say this, okay? Just watch the screen. Watch the screen real quick. We always want that first term inside the parentheses to be positive. We always want that, okay? So right now, if I were to just go ahead and start factoring, I know I would factor out an 8, but I would still have this negative sign. Does that make sense, everyone? So whenever the first term is negative, you're going to factor that out as well. Okay? And it's because we want that first term inside the parentheses to be positive. Does that make sense? All right. Now let's look at the letter B. We have b to the sixth, b to the fourth, b to the second. The smallest exponent is b to the second. Are there any questions so far? This is the first, I think, kind of difficult factoring problem. All right, now can somebody tell me, what am I going to do with my GCF now to figure out what goes inside the parentheses?
Divide it.
Perfect. All right, so I'm going to divide everything by my GCF. And all you got to do is just take your time. Don't rush. Negative 8. Here, I'm looking at the very first term. Negative 8 divided by negative 8 is positive 1. B to the sixth divided by b to the second is b to the fourth. And notice it's now positive, which is what I wanted. Now I'm going to do the middle term. Like I said, take your time. 16 divided by negative 8 is negative 2. B to the fourth divided by b to the second is b to the second. Because 4 minus 2 is 2. Now the last term, negative 8 divided by negative 8 is positive 1. And b to the second divided by b to the second is really b to the 0, and we know that to be 1 as well. So the factored form is negative 8 b to the second times the quantity b to the fourth minus 2b to the second plus 1. How do I check myself? How do I check myself to make sure I'm correct?
Distribute.
Good. So that's exactly what I'm going to do. I'm going to distribute negative 8b to the second to every single term. Watch what happens. All you got to do is just watch. Negative 8b squared times b to the fourth. That's negative 8b to the sixth. Negative 8 times positive 2, or I'm sorry, negative 8 times negative 2 is positive 16. B to the second times b to the second is b to the fourth. And then negative 8b to the second times 1 is negative 8b to the second. And that's exactly what that original problem was. Does that make sense, everyone? If you could, listen, if you can understand this process, then the remainder of the chapter is going to be really easy for us. We'll probably finish this chapter, I'd say, in a week and a half. All right? Next one. How about you do the next one? Not that difficult. Okay. Can somebody just give me the factored answer?
I give 5x
Parenthesis?
x by the third minus 4.
I love it. Good job. Perfect. Let's understand how we got that now. Remember, our GCF is 5x. Okay? So I factor that out and divide all my terms by 5x. 5 divided by 5 is 1. X to the fourth divided by x to the first is x to the third, which I didn't write. Sorry about that, Ramzia. My bad. I didn't write x to the third there. And then negative 20 divided by 5 is negative 4. X over x is 1. All right. Couple more. This next one looks difficult because we have those fractions. But what if I did this? Ready? What if I did this? If I just got rid of those denominators, you would have a 5, a 1, and a 2, correct? Do you see anything common there? 5, 1, and 2. Anything in common?
1.
1, but 1 doesn't change anything, correct, Jada? Like I guess technically you can always factor out a 1. But how many times do you ever see us write this? With a 1 out front? Never. All right? So although I agree with you, a 1, we just never write that. All right? Now, let's do it like this. Is there anything in common here? Yeah, they all have a number 9. More importantly, that number 9 is located in the denominator. Do you guys agree? So my GCF here, watch this. Is going to be 1/9. I can factor out a 9 in the denominator. And remember, that 1 doesn't change anything. Now, let's look at the letter Z. Z to the 5th, Z to the 4th, Z to the 3rd. The smallest exponent is Z to the 3rd. So the only thing I have to do now is just figure out what's inside the parentheses. Here's the beautiful part, all right? I'm going to write this underneath so you guys can see it. If you were to take 5/9, 1/9, and 2/9, and you were just to pull out that 9 out of the denominator, then what you'd have left over is a 5, a 1, and a 2 because you pulled that 1/9 out front. Does that make sense? So if you think about it that way, then the first term is just going to be Z to the 2nd power with a 5 out front. Does that make sense? All right? I mean, if you wanted to, and by all means, you could do this. You can divide those two. All I did was I just took this and just rewrote it. So let's go ahead, let's do it. The hard part. 5/9 divided by 1/9. So you have a fraction divided by a fraction. We know you rewrite the first, multiply by the reciprocal of the second. You simplify if you can. Notice you still get 5 left over. So if you can just visualize taking that 9 that's in the denominator and just pulling out front, that's going to save you a lot of, I guess, hardship when it comes to just figuring this out. The only thing I'm going to do is just divide everything by Z to the 3rd. So I get 1Z plus, minus 2. I don't need that 1 there. Does that make sense, everyone? Factoring out a fraction may seem like it's a lot more, it's more difficult, but it's not. All you have to do is just move that denominator out front. Once you do that, the coefficients just stay there. 5, 1, and negative 2. Okay? All right. Couple more. Let me see. Here, you know what? I'm going to leave this up here for a second because I don't know. I think I'm moving fast. I really think I'm moving fast. Am I moving fast, Hannah?
No, you're good.
Hannah, did you email me about you bumped your head? Was that you?
Yeah, that was me.
How you feeling? You okay?
Yeah, I'm better.
Oh, good. Yeah. I remember. You must have hit your head pretty hard.
Yeah.
All right. I've done that before. Don't worry. Trying to think, when was the last concussion I had? I've had a couple of them. I got him playing football in high school. What about out of high school? The last time I got really hit in the head, I got hit in the head with a hockey puck when I was playing hockey. But I was wearing a helmet. I played goalie. And my ears, they rung for like a day and a half. But that's the last time. That's all I can think of. There you go. There's a little commercial for you. A little break from the action. I got hit in the head with an ice hockey puck. Trust me, it hurts. All right. Number 10. Now, number 10, it looks crazy. But if we just take our time, it's actually very easy. Let's find our GCF. Now, I'm not going to write everything out. I'm just going to look. 8, 20, and 12. Now, it looks like to me, a 4 is what's in common. Because I can divide 8, 20, and 12 all by 4, and I still get a nice number. Now let's look at the letter A. We have 8 to the second, 8 to the third, and 8 to the first. Smallest exponent is 8 to the first. Let's look at the letter B. We have B to the fourth, B to the third, and B to the third. So the smallest exponent is B to the third. I know my GCF is going to be 4AB to the third. I will come in and just write that underneath. And now let's just simplify to find out what goes in the inside of the parentheses. 8 divided by 4 is 2. 8 to the second divided by A is A. And B to the fourth divided by B to the third is B. Middle term. Negative 20 divided by 4 is negative 5. A to the third divided by A is A to the second. B to the third divided by B to the third is 1, so it just stays the same. Last term. Positive 12 divided by 4 is positive 3. A divided by A is 1, and B to the third divided by B to the third is 1. So, my factored form is 4AB to the third times 2AB minus 5A squared plus 3. How are we looking so far? Pretty good? All right, now, the last problem, how would you approach this? Talk to me here. What do you think we do? If you were to tell me how to do this problem, or at least if we were working on this problem together, what would be your first move? What do you think?
We remove the parentheses.
Now, I like what Ramzi has said, but I don't agree with it. So, here's what Ramzi has said. Remove the parentheses. In other words, take the 8 and distribute it. Now, like I said, that's a correct math move. You are allowed to do that. But it doesn't help us here. Okay? Now, I want to show you something. Notice both terms have a y minus 2 in common. Do we agree with that? Yes or no? I mean, if you think about it, the 8 times y minus 2, that's already factored. Remember, factored means the multiplication of things. So that 8 times y minus 2 is already factored. The x times y minus 2 is also already factored. But when I look at just those two terms, the first one, 8 times y minus 2, and the second, x times y minus 2, they both have a y minus 2 in common. My GCF is y minus 2, which means I can factor that out as well. So watch what happens. If you just want to watch a screen, go for it. I'm going to erase this real quick. I know once I establish the GCF, I divide everything by it. What's left over inside this parenthesis? Well, y minus 2 over y minus 2 is 1. They reduce. What's left over? That number 8. Y minus 2 divided by y minus 2 is still 1. They reduce. What's left over? A positive x. And that's your answer there. So, anytime you see parentheses in your factoring, you have to fight against that urge to remove the parentheses. Because sometimes, like in this problem, it's already factored. You're looking for things that are common between the terms. Remember, that's what you're looking at. Okay? Are there any questions? All right, well, if you want to, you can go ahead and write that down. I'm just going to do this. We're actually going to see this one example that we just did. We're going to see this a lot in the next examples. Okay? All right, so the last objective in this section, and I'm going to be honest with you, I think the first section is the hardest because you're learning. This is all brand new. All right, the first section is the hardest. The last one we're going to look at is factor by grouping. I think it's the last section. Let me check my notes real quick. Yeah, it's the last section. Okay. So, factor by grouping. Now, this entire lecture so far, I'm asking you to find a GCF. Okay? And remember, a GCF is something that is common between every single term. Look at this example right here. I'm asking you to factor xy plus 3y plus 4x plus 12. Forget about the factor by grouping part where it says factor by grouping. Let's look right here. xy plus 3y plus 4x plus 12. If I were to find a GCF, first thing, look at the coefficients. You have a 1, which is out front there. You have a 3, a 4, and a 12. Is there anything common for all 4 coefficients? Now, remember, 1 doesn't count. Is there a number that I can go ahead and write divided by and put this number underneath, and I always get that nice whole number answer? Is there a number that exists? Yes or no?
No.
I agree. I agree with, I think that was Gabrielle. I agree. Yeah, there is not a number that exists. So there's no coefficient GCF. What about the variables? What about the variables? Let's look at them. Well, yeah, in the first term, you have an xy. That's pretty nice. Second one, you have a y. The third term, you have an x. But this last term, it doesn't even have a variable. So is there a variable that's common for every single term? I see Jada shaking her head no, and I agree. you do not have a GCF here. There isn't one. Okay? But that doesn't mean you can't factor this. So if you look at what I have right here, and I'm just going to erase this now. We don't need this anymore. A key to using the technique called factor by grouping, a key is just to count the number of terms. If you have 4 terms, we need to think factor by grouping. Okay? I want you to look at all the previous examples. The previous examples, we had 2 terms. We may have had 3 terms. This is the first time that we actually have 4. So when you see 4 terms, and I'm going to count them off for you. 1, 2, 3, and 4. 4 terms. You should be thinking factor by grouping. What's nice about this? There's a technique. There are steps. So step 1, you're going to group the terms into groups of 2. So let me show you what I mean here. Notice I grouped the first 2 terms and I grouped the second 2 terms. And I put an arrow to that middle sign. That middle sign, no matter what it is, will never ever be grouped. You always leave it in between the 2 sets of parentheses. Does that make sense, everyone? Okay? I'm recording the lecture. Definitely go back over and watch it again if you're having issues. Ask me if you have any questions as well. So, step 1, create your little groups. Never group the middle sign. Never. Okay? So I'll just put like a little step 1 here. Step 2. I'll write it down here. We're going to factor out what I call a mini Gcf. Okay? We're going to factor out a mini Gcf. So the book doesn't call this a mini Gcf. It just says factor the Gcf. I like to call it a mini one. Here's why. Watch what happens. I need everybody just to watch the screen. If I look in that first set of parentheses, the xy plus 3y, since I grouped that together, now there's a little GCF there. And it's going to be the letter y. Because both terms have a letter y in common. What's left over is x plus 3. So if I factor out the y, I'm left over with an x plus 3. Does that make sense so far, everybody? Okay? Copy the plus sign. Now, if you look at that second set of parentheses, there's a mini GCF there. Notice 4x plus 12. I can factor out a 4. What's going to be left over is the x plus 3. What's beautiful about factor by grouping is now, that was step 2 by the way, is now in step 3. If there is a common binomial inside the parentheses, factor. I will use the same exact color of highlighter that I used before. Notice both new terms have the x plus 3 in common, which means I can factor that out. And if I factor out the x plus 3, whatever is not highlighted is what will be left over inside your parentheses. And there's your answer. So, xy plus 3y plus 4x plus 12 factors into the quantity of x plus 3 times y plus 4. This technique of factor by grouping is so important because we will use it a lot. Okay? What's also nice about factor by grouping, and I'm going to put a star right next to step 3. Step 3 is like a built-in check system. In other words, you're going to know if you're doing this problem correctly because whenever you factor out your mini GCFs from step 2, those parentheses should always match. What's ever left over inside the parentheses after step 2 should always be the same. If they're not the same, then something happened. Either you screwed up a sign somewhere, which we're going to see in a little bit, or maybe you actually have to just start over again. And that's what step 4 says. Step 4 says, if step 3 fails, in other words, if those things inside the parentheses don't match, try to rewrite the problem by rearranging the terms and try it again. We will see a problem like that later, where we do this and it fails and we have to rewrite it because we got to mix the terms up. Okay? Right now, we just need to know the process. So, let's zoom out here a little bit. Leave my steps up there. We're going to go ahead and do number 12. Okay? So, if you want, you can watch. If you want, you can follow along. All right? 15x to the third minus 10x to the second plus 6x minus 4. We're going to factor by grouping. Okay? Step 1. Let's go ahead and group. Remember to never group that middle sign. Always leave it in the middle. Okay, so that was step 1. Step 2. Let's factor out that mini GCF for each group. In the first group, they both coefficients have a 5 in common, and the variable is x to the second. So what's left over? (3x minus 2). Remember, you're dividing by 5x squared. So 15 divided by 5 is 3. X to the third divided by x to the second is x. Negative 10 divided by 5 is negative 2. X to the second divided by x to the second is 1. Copy down that sign. We're going to do the same thing, but for the second. Let's find that mini GCF. 6x minus 4. I can factor a 2 out, and that's it. So from here, I'm left over with 3x minus 2 inside the parentheses. Am I doing this correctly? Am I on the right path? Yes or no? B, you're shaking your head yes. Can you tell me why?
The terms are the same in the parentheses.
Perfect. When we look inside the parentheses, they're the same. And because they're the same, I can factor it out, which is step 3. I'm going to write it over here. I factor out the 3x minus 2. What's left over is 5x squared plus 2. Let me write that nicer. And that's it. There's your final answer. Okay? Are there any questions? I know this can be a lot. This is, like I said, this is much harder than Chapter 12. Chapter 12, it was just giving me the product, giving me the answer. We are just doing the exact opposite now. I'm giving you the answer. I want to know what are the things that you multiplied to get me there. Okay? Are there any questions? All right. Oh, go ahead. I'm sorry.
How did we find the fact x over 2a plus 2? Can you explain that again?
So how did I find this right here? Or how did I find this?
Yeah, the second one.
Ah, okay. Yeah, no problem. So remember, because you're the one that told me this, I asked you, how did we know that we were doing this correctly? And you said inside the parentheses 3x minus 2, right? So I'm going to divide both of these by 3x minus 2. Do you agree with that? Now, watch what happens. I'm going to take my eraser. 3x minus 2 divided by 3x minus 2. We say they cancel each other out, correct? I'll do the same thing over here.
Okay, that's good.
Do you see it now?
Yeah.
Okay, good. All right. 13. 13, we need to be very careful. All right? In fact, let's put a star next to 13 because this one's super important. All right. So we have 3x squared plus 4xy minus 3x minus 4y. We have 4 terms, so I'm thinking factor by grouping. All right? So step 1 is to go ahead and create your groups. Okay, now, I need everyone to look at the screen, put your pencils down. I'm warning you. Do not write what I'm about to do. Okay? I'm going to say it one more time so everybody can hear me. Do not write what I'm about to do. Okay? If I were to proceed with step 2, remember, don't write this because it's wrong. I'm telling you it's going to be wrong. If I proceed with step 2, watch what happens. In the first set of parentheses, I could factor out a little x, and that's fine. That's what I did. In the second set of parentheses, I couldn't factor anything out. There was no GCF, and that's fine. That could happen. But look what happens. We're going to go back to B. B, am I on the right pathway here? Yes or no? No. Watch. Everyone should be saying this. Do not write this. They're not the same. They are not the same. Notice one has a plus sign and the other one has a minus sign. And here's why, and here's where we made our mistake. Our mistake was all the way back in step 1. And it was that little minus sign in between. So here's what I need you to write. Now, if you want to, you can pick up your pencil, you can write this. Write exactly what I have. Draw an arrow to that minus sign and put when the middle sign is a minus, comma, you must When that middle sign is a minus, you must change the last sign. Okay? There are no ifs, ands, or buts about that. You have to change. So, in my second set of parentheses, that 3x minus 4y, because that middle sign is negative, I have to make it positive. That second sign has to change. Okay? That is going to be the number one mistake that you will make when you're doing these problems. Is you will group, and if that middle sign is negative or a minus sign, if you don't change that second sign, that last one, it's going to be game over for you. Okay? Now watch what happens in step 2. I could still factor out the x out of the first grouping. But hopefully now you can see we're on the correct path now. Because inside the parentheses, match. 3x plus 4y and 3x plus 4y. Does that make sense, everyone? All right? That is the big thing that I need you to learn here. All right? So since the parentheses match, I can go to step 3, which I'm going to factor out whatever matches. In this case, it's going to be 3x plus 4y. Can somebody tell me what's left over? What's going to go into second set of parentheses? If you truly understand what you're doing, you'll get this right. If you don't sweat it. Remember, we're learning this. This is a learning process here. So, who said that? Very, very good. Now, can you explain why we get the x minus 1? Because I guarantee you this, Jada, there's going to be at least one person in the room right now that has no idea where that minus 1 came from.
I divided both terms with 3x plus 4y, and the second term was, I got 1. I don't know how to explain.
You are absolutely correct. Remember, when you're factoring out the 3x plus 4y, that is the GCF for both of those terms. So you're dividing it. 3x plus 4y plus 3x plus 4y, or I'm sorry, 3x plus 4y over 3x plus 4y, that turns into a 1. So you get x minus 1. Jada, awesome job. Awesome job. Are there any questions? All right, let's do the last couple. We got 3 more. So, let's look at 2a squared plus 5ab plus 2a plus 5b. How many terms do we have? Can somebody tell me?
4.
4. So what should we be thinking, Samantha? What technique?
The one we just did.
And what's that called?
Factor by grouping.
Factor by grouping. You see 4 terms, think factor by grouping. So step 1. Why can I can't write the word step. So we factor that middle, we group them. That middle sign is a plus. So I don't have to worry about changing signs. That's good. That's the best case scenario for us. Step 2. Let's do the Mini Gcf. So it looks like I could factor out an A. In the second grouping, there's nothing I can factor out, and that's okay. That'll happen. The key, does the stuff inside the parentheses match? Yes or no? If it matches, and I see people shaking our head, yes, I like that. If it matches, then you know you're on the right path. So step 3, let's factor out the 2A, 5B, because that's what matches. And hopefully, everybody can see that A plus 1 is left over. Does that make sense, everyone? Let me explain why, because maybe we don't really see it. Let me explain why real quick. We know that since the 2A plus 5B is inside the parentheses and it's common, we're going to factor it out. We also know this, and you got to remember this. This goes all the way back to chapter 12. Inside the parentheses is 2A plus 5B. And that is raised to the first power. When the bases are the same, you subtract the exponents. And what is anything raised to the 0 power? It's 1. That is how we're getting the 1. Because let's be honest, if you knew what A was and you knew what B was, in other words, A and B would be numbers. You would simplify inside the parentheses and you'd get a number raised to the first power. That's what you would have. So don't overcomplicate this. The only thing is you don't know what A and B are, so you just got to kind of let them ride along the problem with you. Okay? Let's do the next one. Am I moving too fast or are we okay? Because factoring, I can really start to move fast. All right, let's look at this next one. Okay, now, if you're writing in pen, I'd wait. If you're writing in pen, I would wait. Step 1. Let's do our grouping. 3xy plus 2 minus 3xy, or I'm sorry, 3x plus 2y. Remember, that middle sign is negative. So that last sign has to switch. So it was negative at the start of the problem. When I create my grouping, it has to be positive. Okay? How are we looking so far? All right, now, step 2. I look inside the parentheses, 3xy plus 2. There is no GCF there. And the second set of parentheses, 3x plus 2y. There is no GCF there. Uh-oh. Uh-oh. This is the first time where the stuff inside the parentheses doesn't match. So according to our steps, in step 3, if it doesn't match, you got to start over again. Now, how did I know that? Well, we saw that negative sign in the middle. We switched the second sign. So I know my grouping, switching that sign. I know all that's correct. Here, I'm stuck. So I literally have to start all over again. It's just this time, I'm going to rewrite the problem. I'm going to mix up these terms a little bit, okay? So let's try this. All I did is I took the plus 2 and the minus 3x and I just switched them. That's it. It's like me writing in cursive versus print. I just wrote it a different way. Now, let's try step 1 again. So step 1, let's create our groups. And that's awesome. That middle sign is positive. That middle sign, excuse me, that middle sign was positive. So I didn't have to change anything. Step 2, let's factor out the 3x. Okay. Oops. In the second set of parentheses, I can factor out a 2. Wow, look how close that is. Can anybody see it? Look how close that is. I have inside of the parentheses y minus 1. Over here, it's 1 minus y. Let me write it like this so you can actually see what I'm talking about. Because I can see it, but then again, I've been doing this for a long time. All I did is inside the parentheses for the second parenthesis, I just wrote it so the variable was first and the number was second. Notice they're exact opposites of each other. The y is positive in the first set of parentheses, but in the second set it's negative. The 1 is negative in the first set of parentheses, but in the second set it's positive. What is one way that you know of that you can change signs?
Change the middle sign.
And how am I going to change that? You're correct. Actually, let me write it like this. Now that you saw it rewritten. I can factor out a negative 2. Remember, and I know I went over this in chapter 12 when I said a negative symbol or a negative sign in front of parentheses switches signs. So, if I factor out a negative 2, I get negative 1 plus y. Remember, all it does is switch signs. But if I just rewrote it, now I have the thing inside the parentheses that match. And then on to step 3. You could finally factor out that y minus 1. This problem, difficulty 1 to 10, this was a 10. I think this is the hardest problem that we've done the entire semester. I can guarantee you this. If this problem were to appear on a test, you would only have one of them. That's it. Okay? All right, you know what we're going to do? We'll come back to 16. Nah, you know, we'll just do it now. No, we're going to come back to it. Sorry, I'm changing my mind a lot. All right, so section 1 is done. Like I said, we will revisit because it'll be a lot easier once I give you this one article, this one thing that you can have. All right? This is the hardest section because it's the first time you're seeing any of this. All right? So what I'd like to do is go into the next section. We'll start it. Where is it? Oh, I have to import it. My bad. Because this one is actually very easy. Okay? So this next section is factoring trinomials of the form, and this is very important. All right, all I'm going to do, we're basically talk about this. This is very important. The form is x squared plus bx plus c. In other words, you have a coefficient of 1 out front. Okay? Now, if you think back into chapter 12, we did a lot of problems where we had a binomial times a binomial, like x plus 3 times x minus 1. All right? And if you noticed, when we had a binomial times a binomial, the answer was a trinomial. There were exceptions, but I told you they were exceptions. So like, for example, and you don't have to write this down, x plus 3 times x plus 1. Well, we know to distribute, you'd get x squared plus 3x, and then you'd get plus 3x plus 3 for a final answer of x squared plus 6x plus 3. Here's what I'm really saying, though. When you multiply two binomials, your answer is a trinomial. If you think about what this chapter is about, I'm giving you the answer. Tell me what you were multiplying to get there. If your answer is a trinomial, then you must have multiplied two binomials. Does that make sense, everyone? Would you like me to do another example like this? All right. So here's what we're looking at. And this is what I have right here. Thus, if we wanted to factor trinomial, it's going to be the multiplication of two binomials. All right? We got steps. Step 1, write the multiplication of two binomials. Step 2, determine your signs. I'll show you how to do that. And then step 3, you're going to find factors that do these two things. Multiply to get the last term, combine to get the middle coefficient. All right? So let me show you what I mean. Here, we have a trinomial. So I know its factored form has to be the multiplication of two binomials. I put an x and I put an x. Why? Because I know, let me write it like this. I know x times x equals x squared. Does that make sense so far? So there's step 1. For this section, step 1 is always going to be the same. Two sets of parentheses, put x's. Okay? Step 2, always copy that first sign. Since it's positive, I'm going to make it positive. Now, here's what else I know. This number, which I don't know what it is, and this number right here, and I don't know what that number is yet. I have no idea. But what I know is this. The first number is positive. The second number that I multiply has to give me a positive number. A positive times what equals a positive?
Positive.
So Jada, what you just found are the signs that I needed. You always copy the first one down, and then you find the second one with the information that you have. Let me do that one more time. I copied this down, and I know if that number's positive, and I need a positive number in my trinomial at the very end, that second sign has to be positive. Because a positive times a positive is a positive. Now, I need the factors of 6. There they are right there. 1 times 6 equals 6. 2 times 3 equals 6. Now, if you look at step 3, find the factors of the last term. These factors should multiply to give you 6 and combine to give you the middle coefficient. Our middle coefficient is 5. 1 plus 6, well, that equals 7. So I know that doesn't work. Oops, sorry. What happened here? Come on. So 1 plus 6 equals 7. That doesn't work. But what's 2 plus 3? Wasn't that 5? So I know my answers are 2 and 3. 2 and 3. And there you go. You just factored. I mean, if you think about it, you could check yourself by distributing. X times x is x squared. X times 3 is plus 3x. 2 times x is plus 2x. 2 times 3 is 6. And when you combine everything, you get x squared plus 5x plus 6. All right, and that's it for today.